Hello class. In this video, we are going to cover the first three sections of chapter 11. The fundamental counting principle, permutations and combinations. Let's start from the first section. And I want you to relate the fundamental counting principle to one example only. Let me show you my example. Let's say you need to go from city A to city B and then to city C. Or you need to go from A to C passing through B. And we know from A to B we have two different routes. From B to C we have three different routes. Then consider how many different routes do you have going from A to C passing through B. This is the only example I want you to remember. And every time you think about fundamental counting principle, I want you to please remember this, recall this example. So from A to B, two different routes. From B to C, three different routes. Then how many different routes do we have from A to C passing through B? You can pause and answer. The answer is 6, is not 5. From A to B, we have two different routes. From B to C, we have three different routes. And we are going to multiply the two numbers, 2 times 3, to get the number of distinct routes from A to C passing through B. Please do not add them. Yeah, I can show you. Let's say from A to B, we choose the northbound. This is one route, right? 2, 3. And what if we, from A to B, we choose from the other route? And we can go from here, 2, 3, another 3. So 3 plus 3 is 6, right? Do you see that? So fundamental counting principle tells us if we are about to complete a task and the task has 2 or more than 2 steps or parts, then the number of ways to complete the task equal to the multiplication of the number of ways to complete each steps. All right. For example, in this example, our task is to go from A to C passing through B. And we have 2 parts in this example, in this task, or 2 steps to complete this task. The first step is go from A to B. Then we have 2 different routes, right? And second step is go from B to C. We have 3 different ways to complete the second step. Then we multiply the 2 numbers. We got the total number of distinct ways to complete the whole task. That is the so-called fundamental counting principle. The formal definition of a fundamental counting principle, same way, same meaning, is just worded differently. Let's look at it. Let me see if I can keep the picture here. Okay, so the fundamental counting principle, if you can choose one item from a group of m items and a second item from a group of n items, then the total number of 2 item choices is m times n. I think the way I explain fundamental counting principle probably easier to understand than this one. You need to complete a task, and this task has more than 1 steps or more than 1 parts. Then for each step, writing down the number of ways to complete each step, and then multiply all of them together, and you would have the total number of ways to complete the whole task. I can give you another example. Let me give you another example. Let's say, let me find a space to write my example. Let's say you are going to attend a party and you want to dress yourself, right? And let's say you have 5 different tops. 5 different tops. And 3 skirts. And 2 pairs of different heels. Then how many different ways you can dress yourself? That is an application of a fundamental counting principle, right? So your task is to dress yourself. Find the top, find the skirt, and find a pair of heels. And your task has 3 parts. The order in this case really doesn't matter of the three steps. It mattered in previous example. The first step has to go from A to B. The second step has to go from B to C. But in this example, the order even doesn't matter. So you can choose a order from top to the heels. So you have 5 options for the top, 3 options for the skirt, 2 options for the heels. Now how many different ways you can dress yourself? Simply just multiply all the 3 numbers. 5 times 3 times 2, 30. You have 30 different ways to dress yourself. I hope after this second example, you can have a clearer understanding about fundamental counting principle. Yeah, just once you read the question, find the task, and then find the parts or steps in the task. Let's do the examples. Example 1, a restaurant offers 10 appetizers, 15 main courses. In how many ways can you order a 2-course meal? What's your task here? Your task here is to order a 2-course meal. So your task has 2 parts or 2 steps, right? Your task has 2 parts or 2 steps. Yeah, let's say you order the appetizer first, and you have 10 options. Fundamental counting principle, so we're multiplying, not adding. And the second part is you choose the main course. You have 15 options. Simply just multiply them together, 150. You have 150 different ways to order a 2-course meals. That means the restaurant is able to accommodate 150 different preferences for a 2-course meal. Second example, this is the semester that you will take your required psychology and social science courses. Because you decide to register early, there are 10 sections of psychology from which you can choose. Furthermore, there are 4 sections of social science that are available at times that do not conflict with those for psychology. In how many ways can you create 2-course schedules that satisfy the psychology social science requirement? So here in this example, your task is to choose a psychology social science 2-course schedules, right? The first step is to choose a psychology schedule. How many ways you have that? You have how many different options? You have 10 options. Fundamental counting principle. And the second step, in this case, the order of the 2 steps is fixed, right? You have to choose psychology first and then social science. Knowing that doesn't affect how do you apply the fundamental counting principle. Just to follow the order. If the order makes sense in this the task, you have to do a certain step the first, the second step the certain step the second, then you just follow the order. So the first step, psychology, you have 10 different options. Second step, to choose a social science course, you have 4 options. 10 times 4, 40. You have 40 different options to create a 2-course schedules to satisfy your requirement. Let's see this box, fundamental counting principle. The number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. The key word is multiply. Please remember, when you apply fundamental counting principle, you are multiplying, you are not adding. And the content in this box will be useful when you work on your MATLAB math assignments. Even those definitions sounds very formal, probably not very easy to understand, but that describe the fundamental counting principle. Let's look at this example. Example 3. An apartment complex offers apartments with 4 different options, designated A through D. Option A is about bedrooms, how many bedrooms the apartment has. 1 bed, 2 beds, 3 beds. Option B, not option, category B. I'll describe category B is about the bathroom, 1 bath or 2 baths. Category C is the first floor or second floor. Category D is the view, lake view, golf course, no special view. How many apartment options are available? Describe 2 such options. What's your task here? Your task here is to choose your apartment, right? Then you have to go through all the 4 categories, A, B, C, D. And you want to decide, you want a 1 bath or 2 baths or 3 baths, right? So the first step, we follow the order A, B, C, D. Even if you mess up the order, it doesn't affect the result. So let's follow the order A, B, C, D. So the first step is to choose a bedroom. You have 3 different options. Second step is to choose the number of bathrooms. You have 2 different options. Step 3 is to choose first floor or second floor, 2 options. Step 4 is to choose views. You have 3 options. Just simply multiply all of them together. 3 times 2 times 2 times 3, 36. You have 36 different options, or 36 apartment options are available. Describe 2 such options. I'll just describe 1, and then you try 1, okay? My option, I would choose apartment. I would choose a 3 bed. So I would choose this one because I want to have a bigger family in the future to prepare for that. And 2 bath. Second floor, because first floor might be, because I like being quiet. Second floor will not have people, have any noise from above. And I like lake view, so that's my option. Okay, you can choose your option. So this is example 3. Example 4. You are taking a multiple choice test that has 8 questions. Each of the questions has 3 answer choices, with 1 correct answer per question. If you select one of these 3 choices for each question and leave nothing blank, in how many ways can you answer the questions? So this is about what task? Complete a task. Your task is to complete a task. And how many questions in this test? Says 8 questions. Yeah, 8 questions. So your task has 8 steps. Okay, let's follow the order. First question, second question, and last question. So you have 8 steps to complete in order to get this task done. And let's see the first step. Answer the first question. And the first question, same with all other questions, is a multiple choice question. You have 3 answers. We assume you have no idea what the answer is. You just simply guess, like you are a robot. And choose 1 from the 3, so you have 3 options, right? Each of the questions has 3 answer choices, so 3. So the first step, you have 3 options. Second question, you have 3 options. Third question, 4, 5, 6, 7, 8. So you have 3 to the power of 8. That many different options. Yeah, use your calculator. Calculator, a good calculator is still important in this chapter. Could help you save a lot of energy. So the answer is 6,561. You have this many options to answer this test. Question number 5. The local 7-digit telephone number in Inverness, California have 669 as the first 3 digits. How many different telephone numbers are possible in that town or city? So when I see the telephone number has how many digits? 7 digits right here. So this is what I usually do. I would draw a 7 boxes next to each other. 1, 2, 3, 4, 5, 6, 7. So let's erase that. Seven digits, right? Each digit goes to one box. 1, 2, 3, 4, 5, 6, 7. Since in that city, the first 3 digits has to be 669. Then we do not have to make any decision on the first 3 digits, right? Yeah. What do we need to do? Our task here is to figure out the digits for the next four boxes, next 4 digits. All right. Yeah. How many different telephone numbers are possible in that town? So our task has 4 steps. The first step is to put a number here, a digit here. Second step is to put a digit here. Third step is to put a digit here. The last step is to put a digit here, right? Yeah. So how many digits do we have to put each cell? The digit could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 digits could fill in the cell, right? Okay, so this is what we do. We apply the fundamental counting principle. So the first step, we have 10 options. Second step, we have 10 options. 10 options. Last digit, we have 10 options. So we have 10,000. That many different options. Local 7-digit, yeah. We only have 10,000. So that means what? That means in that town of the California, we only have 10,000 different telephone numbers are available, possible. If the population increases in that town, they probably would do this. That happens all the time, right? They probably have to add 1 more digit here. That way, there will be 100,000 possible telephone numbers. Does that make sense? Number 6, how many different 4-letter radio station call letters can be formed if the first letter must be W or K? Okay, so the code radio station call letters can be formed. Yeah, so we are going to, our task here is to form a 4-letter radio station call letters. Okay, then I'm going to draw a 1, 2, 3. This is my 4-letter radio station call letters, right? So I have 4 steps in this task. This is my task to form a 4-letter radio station call letters. And my first step, first letter. The first letter must be W or K. How many options do we have? It says is given. It tells you the first letter must be W or K. So the first step, the first letter has to be W or K. So the first step of the task only has 2 options. And the second letter, did it say anything specific about the second letter? It doesn't, right? Yeah. So the second letter could be any letter, could be any one of the 26 letters, right? And the third letter could be any of the 26 letters. Same with the last one. Let's see what's the answer. 26 to the power of 3, 26 cubed multiplied by 2. 35,152. That many different options. Okay, yeah. You have this many options for the radio station call letters. Yeah. Knowing the first step, you only have 2 options. Yeah, the process to apply fundamental counting principle is to identify the task and then see the steps or parts and then write down the number of ways to do each step and then you multiply them all together. And that's the last one. Okay, so now we are going to go ahead to start 11.2, permutation. Earlier when we talked about fundamental counting principle, I asked you please relate fundamental counting principle with one example, right? From A to B, 2 rows, from B to C, 3 different rows. Then from A to C, passing through B, we have 6 different rows. Then you remember, okay, I'm supposed to multiply them together, right? Not adding. And same with this section, permutations. Permutations, I want you also only remember one example. Remember, understand and remember one example. And all other permutation problems should be able to be generalized from the example. One example, let me give you my example. Let me find a space. I can do it here at the very beginning. Let's say your task here, your task is to select 3 different books from 5 different books. Let's say you only have 5 different books and you just, recently purchased a bookshelf, a very tiny bookshelf, and the bookshelf is very small, so it can only hold 3 books. But you have 5 different books, right? Okay, here your task is to select 3 from 5 different books and then put on the shelf. And then arrange them, the 3 books on the bookshelf. You can word it in your own way. Okay, your task is to choose 3 from 5 different books and then put on a bookshelf. Okay, bookshelf. So let's see, how do we complete this task? Let's try to apply the fundamental counting principle because the task is very clear here, right? So how many steps in your task? 3 steps in your task. The first step would be choose the first book and put it right here, right? Slot 1. Second step is to choose another book, put it in slot 2. And the third step is to choose one more book and put it in slot 3, right? Okay, let's apply the fundamental counting principle. First step, you choose 1 book and put it in slot 1. How many options do you have? You have 5 options. Okay, you can choose any 5 books and any one of the 5 books and put it in put it in slot 1 on the bookshelf. Second step, since you only have 5 books in total, and in step 1 you already got a book and put it in slot 1. So when you choose a book and put it in slot 2, how many books do you have left? Let's say you have 5 books on the floor, the very beginning. You have 5 books on the floor, and you pick one and put it on the bookshelf, slot 1. And then when you take the second book, do you only have 4 books on the floor? So you have 4 options now, right? You don't have 5 options anymore because you already took one. Does that make sense? And the last step, when you choose the third book to put it in slot 3 on the bookshelf, how many books left on the floor? You already took 2, right? You only have 3 books on the floor. So you only have 3 options when you process step 3. All right, so 5 times 4 times 3. How much that is? 60. So you have 60 different ways to complete this task. That's how do we get this problem done by using fundamental counting principle. But you know what? This is a permutation. This is a permutation. What is a permutation? Let's look at the definition. Permutation is a certain arrangement in which every item will be used one time only. No item will be used more than one time. And the order of those items will make a difference. So let's see the formal definition for permutation. A permutation is an ordered arrangement of items that occurs when, number 1, no item is used more than once. Number 2, the order of arrangement makes a difference, right? It's similar with what I just said. So understand permutation as an ordered arrangement of items. So if we have in total 5 items, like we have 5 books, right? And we select 3 from the 5, and then make an ordered arrangement on the bookshelf, and that is a permutation. Yeah, the permutation, the result actually can be represented by using the permutation. What is it? P53. Okay, this is the first time we see this notation. Very important. P, capital P in the middle, because P is the initial of a permutation. And 5 by the left foot, 5 here is the total number of items. In our example, how many books in total do you have? You have 5 books on the floor, so 5. And the subscript on the right, by the right foot, that number must be less than or equal to 5. Because if you have 5 books, you cannot choose 6 books to put on the bookshelf, right? So that number has to be less than or equal to 5. In our example, it's 3. 3 here is the number of items in the arrangement, in the ordered arrangement. Again, the number by the right foot has to be less than or equal to or no more than the number by the left foot of P. So that is the notation of permutation, okay? So I want you to see this is a permutation situation. All other permutation situations can have the same pattern with this example. You have 5 items in total, and you choose 3 from the 5 and make an ordered arrangement. So the order does matter. The order does matter, okay? Yeah. So do you have the dictionary, the first slot, and then the history book in the second slot, science book on the third slot, or the science book in the first slot, dictionary in the second? Those are make a difference. They are 2 different ordered arrangements. Okay, so this is a permutation situation, and the P53, that notation can be used to represent the total number of ways to complete this task, or the total number of ordered arrangement in this permutation situation. Then how do we calculate the P53? Do we always have to use the fundamental counting principle to get a value? No, we have an easier way. So once you identify the P53, the formula to calculate the P53 is we have 5 factorial. I'll explain what does that mean, okay? 5 factorial on the top, and 5 minus 3, 2 factorial on the bottom. And what is factorial? The, you know, how do you say the acceleration? The factorial. In mathematics, it means factorial. 5 factorial. When you see a number, follow with that notation. 5 factorial simply means the multiplication of the first 5 natural numbers. So 5 times 4 times 3 times 2 times 1. And denominator is 2 factorial, so 2 times 1. Yeah, so it's a very straightforward concept to understand. I believe you understand now. Yeah, so numerator and denominator both have 2 times 1. Cancel them. Then you have 5 times 4 times 3. Exactly same with what we had earlier, right? That's how do we compute a permutation. Of course, we have an easier way to do that is to use the TI-84 calculator. Even you don't have a TI-84 calculator, you only have a scientific calculator, you should still be able to find a function to evaluate P53. You don't really have to calculate the manual every single time, okay? So I'll just simply show you how do I use TI-84 calculator to do that. So you firstly enter 5. You first enter 5, and then you go to math. Yeah, I'm simply just show you how do you, and you try on your calculator, okay? You enter math, and then you would see a menu, horizontal menu, and you would go to the right 1, 2, 3, 3 times to enter PRB. PRB represents probability. Okay, 1, 2, 3, probability. And you will see a list of items on this menu. The second one is NPR. Yeah, the second one is NPR. And you're going to enter that. And then you enter 3. And then you enter. And then we will give you the value. Yeah, so let me try again. 5, math, probability, PNR, 3, enter, 60. Okay, yeah, I'm sorry that I did not show you my calculator because switch back and forth the camera sometimes will incur disruption to the recording. I think I make it very clear. How do we evaluate P53? On your TI-84 calculator, you enter 5 first, okay, and then you find the key has math on it, and then you will see a menu, and you to the right, all the way to the right, you choose PRB, probability, and after that you will see a list of items. The second one is NPR, and you enter NPR, and then you enter number 3, and then you enter, then you will have the value equals 60. So this way your calculation of permutation would become a lot easier. You don't have to always use the formula to find the value. All right, please try that. Please try that. If you have any question, just email me. Yeah, and also I think we can do Excel. I can show you very quickly Excel. Find my Excel file. Just one more option. You don't have to use it, but if you want to, this is what you do. Always enter equal and permutation. It will show you PRMUT, right? And firstly, you're going to enter the total number of the items you have, and enter a comma, and then you enter how many items you're going to select from the 5 different items, and complete. You see that? Okay, yeah. So basically you have 3 ways to compute the permutation. If we look at my table note about permutation and combination, yeah, I have the description, detailed description, how do you use the TI-84 calculator right here. All right, so this is a sneaking is a screenshot of the calculator. You enter 5 first, and then you go to math, and then go to probability, and then choose NPR, and then you enter the second number, the smaller number, and then you will have the answer given. Yeah, please try that. So, do you have an idea about what is a permutation now? Permutation, in a situation of permutation, the order of the items make a difference or matters. And all other examples about the permutation would have the same pattern with the example that I gave you. You have 5 books in total, and you randomly select 3 from the 5 different books and put them on the shelf. Since you are putting them on the shelf, you are making an ordered arrangement. Then how many different ways you can complete the task? That is a permutation situation. So the number of ways to complete the task is P53. Yeah, permutation, P53. Permutation of 5 items, choose 3 at the same time. Yeah, let's look at the formal definition of PNR. Right here, the number of possible permutations if R items are taken from N items. That's the formula. And we call this as the number of permutations of N things taken R at a time. So our example, the number of ways to complete task would be the number of permutations of 5 books taken 3 at a time. All right? Yeah, let's work on the example. Yeah, by using the example, you would be able to understand the permutations. The first few examples is about factorial. Okay, yeah, let's just practice them as warm up. Some of you don't like to use a calculator, right? And nothing wrong with it, but make sure you can manually get the correct answer. In this quotient, numerator is 8 factorial. So 8, 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so I can use this as well. Multiply by. And denominator 5 factorial. 5 times 4 times 3 times 2 times 1. And then we cancel the common factor from the numerator and the denominator. Cancel. So the denominator becomes 1. And numerator is 8 times 7 times 6. Right? And then you can use your calculator to figure out what is 8 times 7 times 6. $336. Part B, numerator is 26 permutation. Denominator is 21 permutation. Numerator is 26 factorial. Denominator is 21 factorial. You know, I don't really want to write 26 times 25, 24, all the way to 2 times 1. How about allow me to write the numerator as 26 times 25 times 24 times 23 times 22 and then times 21 factorial. Is that the same? Are they the same? Same thing, right? 26, 25, 24, 23, 22, 21 factorial. Yeah, since 21 factorial is 21, 20, 19, 18, 17, and so on. So it's the same with the numerator. And the reason I write that, because I know denominator is 21 factorial, that will be cancelled. All right, so the numerator would be only have 26 times 25, 24, 23 times 22. So let's do that. 26 times 25 times 24 times 23 times 22. That's a huge number. 7. Let me fix this. 7, 8, 9, 3, 6, 0, 0. 7,893,600. All right. So if you understand part B, you would be able to answer part C pretty fast. Numerator 500 factorial, denominator 499 factorial. Yeah, what's the connection between the numerator and denominator? Could we write the numerator as 500 multiplied by 499 factorial? And that 499 factorial will be cancelled because the denominator is 499 factorial. So it simply is just 500, right? Okay, so what if in my example, the very beginning, my bookshelf is bigger, okay? My bookshelf is bigger. And I'm going to, my task would be choose 5 from the 5 books and make an ordered arrangement on the bookshelf. I have 5 slots. Then that would give us what? P55, right? And what is P55? If we use the fundamental counting principle, the first slot I have 5 options, second slot I have 4 options, third slot I have 3 options, fourth slot I have 2 options, the last slot I only have 1 option. That actually is a full permutation, 5 factorial. So when the two numbers, the one by the left foot and the one by the right foot, when the two numbers are equal, the permutation is a full permutation. And the answer is just a 5 factorial. Yeah, we're going to see that as a special case of the permutation. Okay? And on the calculator, you can also find the factorial. How do you calculate the factorial? So let's start to work on the example. And the key is, I want you please see the pattern. I want you please see the pattern. Yeah, does this problem have the same pattern with the example that the teacher gave in the very beginning? Choose 3 books from the 5 different books and make an ordered arrangement on the bookshelf. Yeah, let's see. Example 1. You and 19 of your friends. So that's how many people in total. You and 19 of your friends. So that's 20 people in total, right? Have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, CEO, and a CEO, an operating manager, and a treasurer. In how many ways can those offices be filled? Okay, so basically you have 3 slots, right? You have only 3 offices, CEO, OM, operating manager, and a treasurer, right? So what is your task here? Your task here is to select 3 from 20 people, including you, and make an ordered arrangement. Yes, order here matters. You are the CEO, I'm the OM. Let's say Mike is the treasurer. Would it be different from Mike is the CEO, you are the OM, and I'm the treasurer? Do you see what I'm talking about? So this is a permutation situation. Do you see the same pattern? Do you see the problem? This problem has same pattern with choose 3 books from 5 different books and put on the bookshelf. is an ordered arrangement, right? So P23, if you want to manually calculate the value, you can do 20 factorial in the numerator and 20 minus 3, 17 factorial in the denominator. And you have 20 times 19 times 18 times 17 factorial. 17 factorial would be cancelled, and your answer would be 20 times 19 times 18. Let's see, what is that? 20 times 19 times 18 gives us 6,840. If you don't mind, do those calculations. Or you can simply do the TI-84 calculator, right? The app in the TI-84 calculator. You enter 20 first and go to math and go to the right 3 times, PRB, probability, and go down to select NPR and then enter 3, because you only have 3 slots, and you will have the same answer, 6,840. Okay, I'll leave the calculation part to yourself to figure it out. Our focus here is to identify a permutation situation and really see the pattern. All the permutation problem have the same pattern with the example that I gave you at the very beginning. Number 2, you're working for the classic sitcom television network. Your assignment is to help set up the television schedule for Monday evenings between 7 and 10 p.m. You need to schedule a show in each of 6 30-minute time slots, beginning with 7 to 7:30 p.m. and ending with 9:30 to 10 p.m. You have 13 sitcoms from which to choose. How many different programming schedules can be arranged? It doesn't say the order matters. Yeah, most of the times the problem will not tell you directly. Does the order matter? Does the order make a difference? You would have to make the judgment yourself. Does the order matters? Yes. Whenever it comes to scheduling, like a show, put on a show, performing, of course the order matters, right? Yeah, which sitcom you want to see the first, which sitcom you want to see the last. This is all about the ordering. Yeah, so you are making an ordered arrangement. So this is a permutation problem, okay? And you have 6 slots. Sorry, you don't have 6 slots. You have how many options? 13. Yeah, you have 13 sitcoms to select from, but you only have 6 slots, right? Yeah, you see the number by the right foot always is smaller, sometimes equal to. In this case, it's strictly smaller than the number by the left foot. Okay, yeah, use your calculator to figure out what's the result. If you don't mind, you can do 13 factorial over 13 minus 6 is 7 factorial, but that's gonna takes a lot of a little bit while to get the answer, right? Or you can use the calculator. 13, enter 13, and then math, PRB. Yeah, I'm only describing. I hope you are able to figure it out yourself. And the NPR, and then yeah, let's do that again. Sorry, 13 math, probability, NPR, and enter 6. That's a huge number. We have 12,35520. 1,235,520 different options to make that arrangement. Yeah, make sure whatever the methods you use, you have the same answer with me. Next topic is about the permutations of duplicate items. And this part explains very in detail how do you understand if we have repeating items in the items that we choose, the number of permutations will be different, will be less. Okay, yeah, take time to read that part. I'm going to go straight to explain how do you apply the formula here, all right? Permutations of duplicate items. And you need to understand this concept because I remember in my lab math, there's a few questions that about the definition. The number of permutations of n items where p items are identical, q items are identical, r items are identical, and so on is given by this formula. What formula? Numerator is n factorial. Denominator is p factorial times q factorial times r factorial, and so on. So if you don't feel very clear after reading the content in the box, let me show you the examples. Let's do the examples here. In how many distinct ways can the letters of the word Mississippi be arranged? Okay, so let's firstly pretend in this word, none of the letters are the same. For example, we have 1, 2, 3, 4, 4 i's, right? You can see this as a 1, I sub 1, and this I sub 2, this I sub 3, this I sub 4. And as you can see this as I sub 1, I sub 2, I sub 3, I sub 4. And we have 2 p's, you can see this as p sub 1 and p sub 2. Yeah, I'm saying assume, just pretending no letters are repeating in this word. Okay, then how many distinct ways can the letters of the word be arranged? So how many letters do we have? Let's see. How many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's do it again. 5 here, 5, yeah, 11. So pretending all the 11 letters are different. Now, of course, you have P11, 11. That is 11 factorial, right? Yeah, pretend no letters are the same, no identical items. Then we have 11 factorial, that many different arrangements, right? Yeah, pretend no letters in the word are identical. Then we have 11 factorial, that many different ways to arrange those letters. However, we do have repeating items, right? Yeah, P is by itself. We have no repeating. I, how many I's do we have in Mississippi? 1, 2, 3, 4. We have 4 I's, okay? Yeah, think about the 4 I's. I sub 1, I sub 2, I sub 3, I sub 4. If you only arrange those 4 I's, pretending they are all different, then how many different ordered arrangements do you have from the 4 I's? You have 4 factorial, that many different ways, right? But now they are the same. So you have to remove the factor. So you have to divide 11 factorial by 4 factorial. You have to put 4 factorial in the denominator. And that's not the whole story. We also have S, 1, 2, 3, 4, 4S. That's another 4 factorial. And we also have Mississippi, 2 P's, 2 factorial. And that's everything, right? ISP, yeah. So you just put them in the denominator, okay? In the denominator. And then you calculate. I will leave the calculation for you to complete. And we have, the guided note has a simple example about as you can see, if we consider 3 letters SET, we have 3 factorial, which is 6 arrangements, right? Ordered arrangements. All the 6 arrangements are different because all the 3 letters are different, SET. But what if the word is Anna? 2 of the letters are identical, right? And if we do the same thing to have the 6 arrangements, then we will end up with those 6 arrangements. However, this one and this one, they are the same. Yeah, the black A and the red A, they actually is blue. Oh, sorry, blue A and the red A, they are actually the same. So those 2 arrangements, they are the same thing because the red A and the blue A have no difference. So this one would be the same with this one, and this one would be same with this one. So that's how do we end up with 3 permutations only. So 6 factorial divided by 2 factorial. That's how we have 3. All right. Let's see if we have any other questions that we can practice. Yeah, that's everything for the second section. Okay, then let's go to the third section. 11.3 is about the combinations. Permutation, the combinations always, we always learn them together. Compare and contrast. What's the similarities? What are the differences? Combination. Again, I want you to remember or just connect one example whenever you think about combination. All right. So your task here is to choose or select 3 books from 5 different books. Yeah, I use 3 out of 5 because only just for convenience. Books, and throw them in the suitcase for a trip. That's your task, okay? You are not making an ordered arrangement. What do you have done? What do you need to do for completing this task is to choose a subgroup. Okay? The order of the items in a subgroup does not matter. Yeah, let me repeat this task. You have 5 books. You only have 5 different books on the floor. And now you're gonna go on a trip, right? You're gonna go to travel, and you want to take some books with you. Let's say you take 3 books with you. Then you just randomly select 3. So the 3 books would be a subgroup of the total books, right? Yeah. So choose a subgroup and then throw them in the suitcase. Since you throw them in the suitcase, the order of the books doesn't matter, right? Just bundle them together. The order of the 3 books that you select in the suitcase does not matter. It doesn't matter which one on the top or which one on the bottom. Maybe you just randomly throw them like a pretty messy way, right? Again, in a combination situation, the order of the items you select does not make a difference. And your task in a combination situation is to select a subgroup from the total number of items. Yeah. So later when we look at the problems, all those combination problems should have the same pattern with this one. Okay. Now how many different ways do we have? We have C53. That many different ways. C is the initial of combination. The capital letter C. 5, 3. So if your task is to select 3 from the 5 items, select a subgroup with size 3 from the 5 items in total, then you have C53, that many different options. How do we calculate? Remember, if the order makes sense, if the order makes difference, we have 5 factorial and 2 factorial here, right? But now the order of the 3 items does not make a difference. So we would have to remove the order factor. So divided by 3 factorial. So the formula is 5 factorial over 2 factorial, 3 factorial. To be honest, you don't really have to remember the formula. Yeah, we have the formula provided in the guided note if you really want to know. N minus R factorial. But we have an easier way to do that, right? The easier way to do that is to use a calculator, TI-84 calculator. By the way, if you have a scientific calculator, please figure out a way to calculate by using the function. There's a way, just because every calculus is different. If you have any questions, just email me. So how do we calculate the C53? You firstly enter 5, okay, and then you enter math. Yeah, push the button, click the button math, and then you're gonna go to PRB, same with earlier, okay, probability. And then in the menu you will see number 3. Number 3 is NCR, right below NPR. Number 2 is a permutation, number 3 is a combination. And then you enter that, and then you're going to select enter 3, and then you enter, and then we'll give you 10. Okay, 10 different ways to select 3 from the 5 different books and then travel with you. Yes, just select a subgroup. Very, very important. In a combination situation, you simply select a subgroup from the total items. The order of the items in the subgroup does not make a difference. Doesn't matter at all. Okay, for the calculation part, I already shown you. Use the calculator. And let's go ahead to work on the examples. Yeah, as you can see here, permutation problems involve situations in which order matters. Combination problems involve situations in which the order of the items makes no difference. Yeah, all it matters is a subgroup. Let's see this example. Determine if the situation describes a permutation or a combination. Do not solve the problems. Okay, so let's see part A. 6 students are running for student government president, vice president, and treasurer. The student with the greatest number of votes becomes president. Second highest vote getter is VP, etc. How many different outcomes are possible? This is a P problem or a C problem. Permutation or combination? Permutation, okay? Yeah, I know it says do not solve it, but I can quickly just get it done to show you how fast it is. P63. This is a permutation problem because the order of the 3, positions matter. As I mentioned earlier in previous section, you are the president, or I am the president, you are the vice president. That make a difference, right? Part B. 6 people are on the board of supervisors for a company. A 3-person committee is needed. How many different committees could be formed? In this task, we are doing a combination. Why? Because we are getting a subgroup of 3 from the 6 people. The order of the 3 people in the committee doesn't matter, does not make a difference. You just care about getting 3 people all together as a subgroup, right? So part B is a combination problem. Part C, BR offers 31 different flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many bowls are possible? So combination or permutation? It's a combination, okay? C31, 3. Yeah, how do you order the 3 flavors in a bowl? It's just to put them together, right? In a messy, whatever. It doesn't matter. It's just subgroup. It's a subgroup. And yeah, C and R is called the number of combinations of n things taken R at a time. So this is the formal way to read it. And this is the formula I gave you earlier. As I said, you really don't have to struggle with those formulas. I'm trying to make your job easier, right? The easier way is to just use a calculator. Yeah, when you do your homework, you can try Excel. Yeah, enter equal and combination if we try to figure out how many different ways we have, if we take 3 from the 5 different books and travel with us, it will tell us quickly, right? Okay, so let's continue and make sure everything's fine. I'm not muting. It's recording and sharing. Example, a 3-person committee. Yeah, when you see committee, it probably is a combination, but read it on. Is needed to study ways of improving public transportation. How many committees could be formed from the 8 people on the board of supervisors? Total people is 8. This is a combination problem. CA3. I'm showing you how fast this type of question could be. And now let's calculate. Enter 8, enter math, go to the right 3 times, and highlighting PRB, probability, and then go down to select number 3, NCR, and then enter 3, and we would have 56. Okay, yeah, whatever the method you use, make sure you have the same answer with me. Number 2, in January 2021, the U.S. Senate consists of 48 Democrats, 50 Republicans, and 2 independents. How many distinct 5-person committees can be formed if each committee must have 2 Democrats and 3 Republicans? And what is our task in this problem? Our task is to form a committee. How many people in the committee? 5 people. But 3 of them has to be Democrats. And 2 of them has to be Democrats, and 3 of them has to be Republicans, right? Do not forget fundamental counting principle, all right? Do not forget fundamental counting principle. Let's see this task as 2 parts or 2 steps. Part 1 is to get 2 Democrats. How many Democrats in total? 48 Democrats. So this is a combination or permutation. It's a combination problem. You are taking subgroup. You are not worried about the order or who is president or vice president. You are simply concerning taking a subgroup. So C it doesn't let me write. Okay, so let me fix it. So C48, 2 Democrats, right? Okay, 2. Yeah. Be careful. Yeah, be careful because sometimes they look very similar. So 48 Democrats, you choose 2 from the 48 Democrats. That's the first step. Multiply, fundamental counting principle, right? And you need you need 3 Republicans. How many Republicans in total? 50. And you choose that 3 Republicans from the 50 total Republicans. And you finish your task. C48-2 multiplied by C53, and that's it. Okay, you find this value in the calculator and find this value in the calculator and then multiply them together. You will see a few similar problems in MATLAB Math. So make the job easier. Today we learned 3 important concepts: fundamental counting principle, permutation, and combination. And I want you please relate each concept with 1 simple example only. And your job when you do your homework is simply just see the pattern. This is the same pattern with that. Select 3 different books from 5 different books and put on the shelf, right? Make an ordered arrangement. So that's a permutation problem. Yeah. Well, okay, this situation is a combination problem because it has the same pattern with the example. Because take 3 from 5 books and travel with you, you are concerning taking a subgroup. The order of the items in the subgroup does not matter, right? And the fundamental counting principle, just remember from A to B 2 ways, from B to C 3 different ways, And from A to C, passing B, you have 2 times 3, 6 different ways. You're multiplying, not adding. All right, guys, please work on your homework. Yeah, do not try to get it behind. This is a very fast-paced course. Email me. Feel free to email me if you have any questions. I'll see you in the next video.